ratios. Just kidding. Ratios. Please don't say that. Okay, so we're going to look at ratios in this video, and the first thing to be able to do with ratios is the nicest thing you can do, and that is simplify them. So ratios are very similar to fractions, and the way they will always phrase this is like this. Well, is 25 ... 30 in its simplest form. So write that ratio in its simplest form. So here we have the ratio. So we want to think of a number that goes into both. So we can think of 5, because it goes into both of these. We can divide both by 5. Make sure you do it on both sides. So 5 goes into 25 5 times, and 5 goes into 30 6 times. Just like that. Okay, and that's as far as we can go. So done, simple as that. So just like fractions, but we'll keep practicing. Okay, write 12 ... 18 in its simplest form. Okay, so a number that goes into 12 and 18, they're both even, so you could divide by 2. Make sure you do it on both sides. Okay, I'm looking at those. Is there a number that goes into both of those? Yes, there is. We're not done. So 3 also goes into those. No. Oops. 3 goes into 6 2 times, and 3 goes into 9 3 times. So just so you can see, we can actually go from the first step to the final step in one jump. So if we just divided each one by 6, so if you could have spotted that straight away, then you would have got there in one jump, but there's obviously no harm in doing more jumps. Okay, so this one's a little bit different. Write 2.7 ... 3.6 in its simplest forms. Now we're looking at a ratio that has a decimal point in, and that's just kind of harder to work with. So again, you want to find a number that goes into both, but I don't really like working in decimals. I don't know if you really do, but it's quite difficult. So what I'm going to do is I'm going to times both sides by 10 first to make them sort of normal whole numbers, and then do what we're used to. So it's just one extra step. So I'm going to times by 10, or times by as many as you need to get rid of this decimal point. Do it on both sides. And there we go. We are back to the steps we like and that we're used to. So what goes into 27? Not that much. 1, 27, 9 and 3. Does 9 go into 36? Yes, it does. Okay, so I'm going to divide each side by 9. And there we go. So that will be how you do that one. So we'll do another example of when there's a decimal point involved, but that's just like one little extra step. Not too bad once you've seen it once before. Okay, write the ratio 1.4 ... 2.1 in its simplest form. Okay, so first of all we have this, and we notice this is a decimal point, which is just kind of inconvenient because we're just not that good at our decimals to know what goes into that. So if we do, again, you can literally do anything to either side as long as you do the same thing to both of them. So let's just start by multiplying by 10. So as long as you do it to both sides, it's absolutely fine. We like this type of example. We can work with these numbers. So let's see what goes into this. 2 doesn't go into 21, so they're not even, so we can't do that. 3 does go into 21, but not 14. 4, no. 5, no. 6, no. 7. 7 goes into 14. 7 also goes into 41. So let's divide by 7. So as you can just hear my thought process out loud, I kind of work up to, does 1 go in, does 2 go in, does 3 go in, does 4 go in? And just keep going like that if you're not too sure. So that's how you do that one. So this is another style of simplifying ratios that you can get asked. So reduced blank, give a ratio, insert ratio here, to the form 1 ... n. So for example, I'm going to go 4 ... 16, this ratio, reduce it to the form 1 ... n. So we're starting with this ratio, and we want to end up with one that looks like this, but we're obviously trying to find n. So what can we do to get 4 to 1? So to get 4 to 1, we can divide by 4, because if we think of the fraction 4 over 4, they cancel. It's 1. So if we divide 4 by 4, we get 1. So if I've done it on this side, I have to do it on this side. So if I divide 16 by 4, I get 4. And that looks very much the same as the form in which we're asked to provide it in, so you can just leave it like that, and then I might just write on the end n equals 4. So that's how you do that. You have to work on getting the 1 there first. Try another one. Okay, reduce the ratio 636 to the form 1 dot dot n. So we're looking for something that ends like that, but we want to know what n is. Okay, so I've got a 6 here, but I want a 1 here. So how do I make that 6 turn into a 1? What have I done there? So the answer is I've divided by 6, because if I do 6 divided by 6, as a fraction it looks like 6 over 6, and we know that that is, because you can cancel those, and that is 1. So we divided on 6 by that side, so we know we have to divide by 6 on this side. So 36 divided by 6 is 6. And yes, that looks very similar, so we know that n is 6. And we've done what they asked us to do. Okay, so here, reduce the ratio 100 centimetres dot dot 0.5 metres to its simplest form. So now we've got units involved, and the units are different units. So first of all, the kind of logical sense would be to put them into the same units. Okay, so first step here, if you've got different units, is convert to the same units and make sure you do the smallest one. So if we have, so this we're just going to convert first of all. So if we follow the column method that I like, so I have metres over here and centimetres over here. In 1 metre, I have 100 centimetres. So to go from 1 to 100, I've multiplied by 100. But if I want to go back this way, I do the inverse, the opposite, so I divide by 100. I want to go from metres to centimetres because I want to change this one into the smaller unit. So if I've got 0.5 here, what I do to get to centimetres is I follow this arrow, so I times by 100, so that's going to give me 50 centimetres. Okay, so now we've done the hard part, so now we can write out the ratio 100 centimetres dot dot, and instead of 0.5 metres, we know that is 50 centimetres, and then we just do the same thing. We can, remove the units if you want, if you just looked at it like that. So what goes into 100 and 50? So 50 goes in, so if we divide by 50 here, you get 2. If we divide by 50 here, you get 1. So then you might want to, put the units back in. So that's how you do that. Convert your units first, always to the smallest unit. We'll do another example. So here we're reducing the ratio 2 litres to 4,000 millilitres to its simplest form, and because they're different units, we have to convert to the smallest unit, which is millilitres. We're converting from litres to millilitres. So if we do our column, we have litres here and millilitres over here. In 1 litre, you can either do this by just remembering it, or you know that milli means 1,000, so there are 1,000 millilitres. So let's work out how we got there. So to get from 1 to 1,000, you multiply by 1,000. So if I was going the other way, I divide by 1,000. So which way am I going? Litres to millilitres, and I have 2 of them. So I do 2 multiplied by 1,000. Ooh, stop there. Which is 2,000. So instead of writing 2 litres now, I'm going to write this as the ratio 2,000 litres to millilitres, to 4,000 millilitres. Okay, and I can ignore the units if I want for now. So I'm left with this ratio here, which can be simplified down. First we could divide by 1,000 to get rid of all the zeros. So we'd end up with 2 to 4 if we divide both of those by 1,000. But we can keep going, so both even, we can divide by 2. If I do it on that side, I have to do it on this side. 2 divided by 2 is 1, and 4 divided by 2 is 2. Let's stick the units back in. And there we go. We've reduced it to its simplest form. Now we're going to move on to something a bit different. Okay, so we're now going to look at scaling up, so it's kind of doing the opposite. So this is more of an applied thing. So I'm going to just set the scene. So I have to make 1 bottle of squash. Okay, so this is my question. To make 1 bottle of squash, I've kind of, lost a few verbs on the way, but 1 bottle of squash makes, you need 100 millilitres of the squash to the ratio 900 millilitres of water. If I want to make 4 bottles of squash, how much squash and how much water will I use? Okay, so 1 bottle, 100 to 900, so squash, water. So this is now working the other way to simplify what we've done. I want to get not 1 bottle, but 4 bottles. So what have I done to get 1 to 4? I've multiplied by 4. So because I've done that here, I'm going to do that to each of the parts here. So if I multiply that by 4, I get 400. And if I do 900 multiplied by 4, I should get 3,600. Okay, so we found the ratio. So we've scaled it up, basically. So we know now we're just going to give them the answer they want. So 400 millilitres of squash, 3,600 millilitres water, or 3 litres, and 600 millilitres of water. So there you can just see that you can work the other way and you can scale it up as opposed to just keep getting smaller and smaller and smaller. Okay, so we've already first thing we did was discuss that ratios are quite similar to fractions, and the way you simplify them is very similar. So we're also going to look at how you can write a ratio as a fraction. So again, I'm going to make a little scenario. Okay, so this is the situation. I've got a flapjack recipe. By the way, this doesn't work, I'm aware of that. And the ingredients are in the ratio, well, some of the ingredients, oats, syrup and butter in the ratio 5 parts to 2 parts to 2 parts. Okay, so the question is, what fraction is oats? So how many things do I have in total? How many parts do I have in total? So this is kind of like working with parts, is quite a key word. So I have 5 parts of oats, 2 parts of syrup and 2 parts of butter. So if I add those up, 5 parts oats, 2 parts syrup, 2 parts butter, that's 7, 8, 9 parts in total. So if I was going to visualise this, let's say this was my mixing bowl, which is a weird shaped mixing bowl. I have 9 parts here, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 of which are oats. So I'm going to give them an oat, 2, 3, 4, 5. So those 5 are oats, 2 of which are syrup, and 2 of which are butter. Okay, so let's pretend that's my mixing bowl and I've got my ingredients in. So the question is, what fraction is oats, or what fraction is syrup, what fraction is butter? I'm just lazy, don't want to write it out. So the fraction of oats, so we're kind of just working with fractions now, is there are 5 oats out of the whole 9 parts. So it's 5/9 of this are oats. What about syrups? There are 2 of the 9ths. So each one of these is a 9th because it's split into 9. And the butter the same, so 2 of those 9ths are butter. So that's how you work out a fraction. So you get the total parts and then you stick the number over the total parts. So we will also look at another example of this. Okay, so the next example, in a family will, so a relative has died, and £5,000 is left to split in the ratio 2 to 3 for Amy and Hannah, which doesn't seem very fair, but, How much money do each of them get? Okay, so very important thing to note in ratio questions is that whoever comes first in the English, so Amy and Hannah, means they're the first one in the ratio, so they write it in order, so that means Amy and Hannah 2 to 3, so Amy is the 2 parts, Hannah is the 3 parts. So, in total, there's £5,000. My ratio is 2 to 3, and that is Amy to Hannah. And just like the recipe example, we need to know how many parts there are in total to divide it up into. So if there's 2 to 3, if I do 2 plus 3 equals 5, I can think of that as having 5 parts in total. So as a drawing again, this would look like, but this time what are we talking about? We're talking about money. So what we're actually splitting here, what this diagram is kind of showing, is £5,000. So first of all, what's £5,000 divided by 5 parts? So basically, what's £5,000 split into each of these, which looks a bit like a piano, and it's saying, so 5,000 divided by 5 is 1,000. So that is basically telling us we split it up into 5 parts. So this is worth 1,000, this is worth 1,000. Okay, so we know how much each is worth, and we know how much each person gets. So we know that Amy gets 2 of the parts. So we know that Amy gets 2 of the thousands. So that is £2,000. And we know that Hannah gets 3 of the parts, so she gets 3 of the thousands. So Hannah receives £3,000. Very, very unfair, but good for our maths. We're going to move on to some exam questions. Okay, so first question, we have a bag of sweets. In the bag are blue sweets and red sweets in the ratio 5:3. What fraction of the sweets are blue? So this is another parts question. So we've got this ratio. So how many total parts are there? So we do 3 plus 5. That means there's 8 parts in total. So let's say we have just one bag, and these are a part. So we've just split, I'll label it bag. So we split it up into the 8 parts. So now we know in the ratio that 5:3, and we know blue comes first, then red, so blue is first. So 5 are blue, so we can go blue, 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 blue. And then 3 are red, so we can say these 3 are red. So now if we just think of that as a fraction, so what fraction of the sweets are blue, then we can see that they're, so the fraction of this bag, which is like, you know, a nice visual representation, we can see that 5 out of the 8 parts are blue. So the fraction that are blue are 5 out of 8. You don't have to do a diagram, but I'm just helping you try and visualise what's going on. You just need to know the total parts and then the number that are blue. Okay, so this is the next question, very similar. A bag of sweets, this time we've got blue sweets, red sweets and green sweets, are in the ratio blue, red, green is 2, 4, 5. What fraction are red? So the same thing, we have our ratio. So we want to know how many parts in total. So we add up all the parts, is 2 plus 4 plus 5, so that is 9, 10, 11. So 11 parts in total. So again, we could draw out the bag, split it into 11, label the blue, red and green and see what fraction it is. We're asked for the red, so the red here is in the middle, so we know that this is the red. So as a fraction, we know we can just write 4. So 4 parts are red over the total amount of parts, which are 11. Okay, so next question, slightly harder. Given that A to B is in the ratio 4:5 and B to C is in the ratio 3:2, find the ratio ABC. So let's say A to B is 4:5. Over here we have B to C is 3:2. Now we need some way of relating these two things and making them similar. So as we can see, both of them have B's in. So if we kind of sync up these B's, we can then compare the A and the C. So the trick is here to get the B value the same, so then we can look at them all fairly. So I've got a B value of 5 and a B value of 3. So I'm going to try and make this the same. So I need a number, we'll divide by both of them. So the easy thing I can do is if I times this one by 3 and if I times this one by 5. So if I times this one by 3, I'll get 15. And if I times this one by 5, I'll also get 15. If I've done it that side, I have to do the same over this side. So 4 multiplied by 3 is 12, and 2 multiplied by, and then this side we're doing 5, remember, is 10. So now I have these two ratios, and as we can see, these are the same value, and they're both B, so writing it A, B, C, we can just write these numbers down there because the B is the same. So B is now 15, and now we can compare A and C. So there we go. We're going to do one more final exam question. Okay, so here we have A, B, C, D lie on a straight line. A, B to B, D is in the ratio 2 to 5. A, C to C, D is in the ratio 4 to 7. Find A, B, B, C, C, D. Okay, doesn't make much sense unless you're looking at what I'm doing. So it says straight line, so we're just going to draw a sketch because there's no way we're doing this without a sketch. Okay, so A, B, C, D. So we'll put A here, and we know that D is at the end. We're just going to focus on this piece of information first. So AB to BD is in the ratio 2 to 5. So we need to stick a B on here, which is kind of sensibly in this ratio. So if I put B about here, I can call this 2, and I can call this 5, because A to B, 2, B to D, 5. Righty-ho, that's not the only bit we've got to worry about. What about this second bit? So we've got AC and CD is in a ratio 4 to 7. Okay, so I now need to put point C on there, so we can look at this. So A to C, C to D is 4 to 7. So if I put C about here, I know that A to C is 4 parts and C to D is 7. This is obviously very rushed. Okay, so in total, this top part has 2 plus 5. This has 7 parts. And this bottom part has 4 plus 7, which is 11 parts. So they've got a completely different number of parts, so we can't really compare them in any way. So we need to try and scale them up somehow so that we can compare them. So the way we can do that is like the last time, if we multiply them by each other. So if I multiply 7 by 11 and 11 by 7, then we should get 77 parts up here and 77 parts down here, and then we can compare them. So I need to multiply this line by 11. So 2 times 11 is 22, so that's the new value for this. And 5 times 11 is 55, so that's the new value for B to D. Down the bottom, same thing, 4 times, but this time we've got to multiply everything by 7. Okay, so now I'm going to rub out the old values so it's a bit clearer. Okay, so now we have our new values and they're all scaled and we can compare them and join them and life's good. Now we go back to the question and find out what it's asking for. So it wants A, B, B, C, C, D. So if we look from A to B, we already know that value, we've worked it out, so that is 22. BC is this gap here, don't know that yet, but we can work that out. But let's go to CD, from C to D, it's this bit here, and that is 49. So we've just got this BC bit to find, and we know that BC, this gap here, is A to C, take away this distance here, A to B, and we know A to C is 28, and we know A to B is 22, so that 28 minus 22 is 6, so we know that BC equals 6, and we can put that in there.